Okay. Near the point of tangency, the tangent line and the function behave very similarly. Near the point of tangency, the equation of the tangent line is the linearization. Wow. I'm going to underline that. When you are asked to come up with a linearization, I want you to know that the equation of the tangent line and the linearization mean the same thing. Okay? Are you good at finding equations of tangent lines? Should be. Have we done it pretty much every day? Pretty much. So we should be good at that. So this, although this is the last section of 2.9, it should, or chapter 2, it should not be the most difficult. Find the linearization. What am I asking you for? The equation of the tangent. Okay. When it says when at A is 1, what does that mean? A and X mean the same thing. Okay. So we're talking about at the point 1, what? What is the Y value when X is 1? 1, 2. Okay. That's the point we're talking about. We want the equation of the tangent at 1, 2. Now, the first part of that is pretty easy, isn't it? What would you write? Anybody? Y. We don't know what the slope is. X minus 1. Okay. Now we've got to find the slope. We've got to find the slope at the point 1, 2. Okay. So how are we going to find the derivative of this thing? Yeah. Yeah, let's keep in mind that f of x could be written as x plus 3 to the 1/2. So what's the derivative of that? We're going to have to bring the 1/2 around front. We're going to have an x plus 3 to the negative 1/2, using that chain rule, times the derivative of what's inside. And what is the derivative of what's inside? Oh, sweet. Okay. Now, this is a fractional derivative. The derivative, let's see. I definitely have a 1 on top, and I definitely have a 2 on the bottom. Where does this thing belong? So x plus 3 to the positive 1/2, or the square root of x plus 3 goes on the bottom. And then times 1. Well, I really don't have to write times 1. Okay. So what is the slope? What is the value of the derivative? What is the slope when x is 1? Point 25, 1/4. Yeah. 1 over 2 square roots of 4, which is 1/4. So my slope is 1/4. And you have now written the linearization. You've found the equation of the tangent, haven't you? Now, our next job is to use the linearization. Use this equation that we've just come up with to approximate the square root of 3.96. Well, 3.96 is real close to 4. What's the square root of 4? So this ought to be pretty close to 2, probably a little bit smaller. Okay. Okay. Now, what am I going to put in the place of x? I'm going to approximate the square root of 3.96. I know that f of x is the square root of x plus 3. So how big does x have to be so that I get a 3.96 under the square root sign? X equals 0.96, doesn't it? So I'm going to use this blue circled equation up here. I'm going to use that. I'm going to say that y minus 2 equals 1/4 of x, you said was 0.96, minus 1. Okay. Y minus 2 equals 1/4. What do you get when you take 0.96 minus 1? Negative 0.04. So y minus 2, what is 1/4 of negative 0.04? Negative 0.01. So y equals what? If I'm adding 2 to both sides, what do I get? Is that pretty darn close to 2? Is it a little bit less? I use the equation of my tangent line to make a prediction. Because it says up here, near the point of tangency, the tangent and the function behave similarly. If we look at some function, this is a square root function. Square roots look like that, don't they? If I draw a tangent line, it hits and then it takes off, doesn't it? As long as I stay pretty darn close to that point of tangency, are the blue and black lines pretty darn close to each other? Yeah. When we get out here, well, then they're not so much. But as long as we're close to the point of tangency, the tangent line and the actual function behave pretty much the same. So we're going to use the tangent line to make predictions for what the value of the function would be. Now, I think there might be one other question. Is this an overestimate or an underestimate? Keep in mind that this is the actual function. But we used a tangent line. Are you guys good on square roots looking like this black curve right here? Okay. I use the tangent line to predict what the value of square root of 0.396 is. Where is the tangent line? Compared to the original function, where's the tangent line? It's above it. If I choose points on that red line, where are they? Are they overestimates or underestimates? Overestimate. Is it going to be important in this section when you've got these overestimate or underestimate questions? Is it going to be important for you to know what the original function looked like? So that when you draw a tangent line to it, what if you had an original function that looked like this? You draw a tangent line, anything you use on that tangent line is going to be an underestimate because it lies under the graph. Okay, so it's going to be important for you to know what the graph of a function looks like. All right, well, let's keep practicing this. Let's see. Well, we're good on equations of tangents. Now, when we change y or change x by small amounts, we call them dy and dx. These are called differentials. And their ratio is the derivative. Have you ever seen the derivative written as dy dx? Yeah, you've seen that, yeah? Good. And what this is this is a small change in y divided by a small change in x. And that's what the derivative is. It's the slope. It's the small change in y divided by the small change in x. So our job here is to find dy if y is equal to x cubed plus 2x squared. Okay, what's the derivative of y? What's another way of writing y prime? dy dx. And what's the derivative of this side over here? We're going to take all of our derivatives with respect to x. What's the derivative of this side? Everybody. Good. So if your job is to find out what dy is, what are you going to do to both sides of this equation? So dy is equal to this 3x squared plus 4x. And you're going to multiply each side by this dx. And that's it. You've done it. You've gotten dy all by itself. This is what the small change in y would be equal to. Now you're asked to find the value of dy if x is 2 and the small change in x is 0.1. Can you just put these values into this thing up here? Do it. You figure out what dy is. Using your calculator, figure out what dy is. Deacon, you got an answer yet? Take that as a no, Ethan. Paige, do you have an answer yet? You're telling me it's 2. Do we have any agreement on that? Good. Answer is 2. So, in this function right here, when x is 2, and you change x by this very small amount, I'm going to predict this is a predicted small change in y. When we make this small change in x, I'm going to predict using slope, using derivative, I'm going to predict that that is the small change in y that's going to occur because of this small change in x. All right, so that's how we find dy. Then there's delta y. Now, does delta y mean the same thing as dy? You know, it kind of seems the same. But in this section, we're making a distinction between delta y and dy. Delta y is found by subtracting the old value of y from the new value of y. Now, here's our previous problem. Let's calculate, and this is an actual change in y. How much does y actually change? as x changes, starts at 2. How big is the delta x here? Yeah, we're changing by 0.1, just like we did in the last one. Our small change in x is 0.1. So what's going to be the change in y? Well, here's how we're going to find delta y and how it's different from dy. What is the value of y when x is 2? 2 cubed plus 2 times 2 squared. What do you get? I think you get 16. Now, in order to find delta y, we're going to take the old value of y and we're going to subtract it from the new value of y. So what I'm going to need is I'm going to need y of 2.1. Now, that's definitely a calculator problem. I got to take 2.1. I got to cube it. I got to add to that 2 times 2.1 being squared. Nolan, you got something? Cool. So how big is delta y? How much is the actual change that occurs? Well, what is the old number subtracted from the new number? 2 point. We predicted, using the slope, we predicted that it was going to change by 2. Well, pretty good prediction. It changed by 2.081. So dy uses the slope and the derivative, where delta y uses the actual numbers that occur as we make this small change in x. All right. Now let's summarize all this. Final slide. Find the linearization. Okay, I want you to find the linearization. I'm going to give you 60 seconds to do it. Then we'll make our prediction together. You got an equation of a tangent line? Is that the equation of your tangent line? Did you find the slope being 5? I mean, the y minus 6, the x minus 2 shouldn't have been an adventure. Everybody see where everything comes from? We happy? Okay, now we're going to use we're going to use the equation of the tangent line. We're going to use this thing to predict y of 2.2. Now, isn't 2.2 pretty darn close to 2? Shouldn't our y value be somewhat close to 6? If it isn't, what do you think? You messed up. Okay. Well, let's see what happens. Y minus 6 equals 5 times 2.2 minus 2. Well, you go ahead. You figure out what that should be. What are you thinking, everybody? When we add 6 to each side, I think we're going to get 7. Okay. So we have to use the linearization. Okay. Good. Now let's do a dy. In order to find dy, what am I going to have to do with my equation right here? Anybody? What am I going to do with my equation? Find the, what is the derivative of y? I would call it dy dx. And that's equal to, what is the derivative of x squared plus x? So what is dy equal to? To x plus 1 times dx. Well, you know what x is, you know what dx is. You figure out what dy equals. What'd you get for a value of dy? Looking good. And delta y is probably going to be pretty darn close, isn't it? I'm going to start out by finding y when x is what? And when x is 2, what do you get? Now, what other y value do you have to find? When x is what? Are you sure it's 2.2 and it's not 1.8? I mean, x changed by this much, but it didn't say it got bigger or smaller. But it's positive, so that means it did get bigger. 2 changed from 2 to 2.2 because the delta x was positive. Now that's calculator time, and what do you get? Simmer, you got something? 7.04, do we have some agreement on that? Okay. So what is delta y? What is the actual change? Not the change that we predicted by using the slope, but what is the actual change in y that occurs? Okay. So this was predicted, and And this was the actual change that occurred. Okay, cool. All right, so at this point then, we're going to work on 5 or 6 problems from section 2.9. Then we're going to move on to the review, which will be due on Wednesday. We'll go over it on Wednesday and then take the chapter test on 2.5 to 2.9.